The three parallel lines theorem states that if three parallel lines intersect two other lines that we're going to call transversals, then they divide the transversals proportionally. And looking at our picture, for example, if we say UW and relate that to Vx, then UW over Vx has to be the same as Wy over Xz, or even if we take the entire length Uy, then we can relate that to the entire length of Vz, and that also has to be the same as the other two ratios. And we could also create a different ratio if we relate UW to Wy. So we're going from left to right. Then that ratio has to be the same as relating Vx going to the right and relating it to Xz. Now these ratios we're creating here going to the right are not necessarily going to be the same as the ratios we created in orange going from top to bottom, but they are the same if we relate corresponding parts. And that is the key here about this theorem. We need to match up corresponding parts. Always match up corresponding parts and be careful to not get some order reversed. Here are some examples. Use the figure to complete the proportions. AB over AF. So what are we talking about? We're talking about AB, the segment that is to the left, and we're relating that to the larger segment AF. So we got the top little segment relating it to the top big segment. And that has to be the same if we relate BC, our smallest right side of the given triangles, to the largest one, FG. So we have the one that is on the right of each triangle, the very little one, relating it to the right big one. Let's do one more together. AD, which is this segment, can be related to the shorter one, BD. So we have the top medium relating it to the top middle, and we're relating that to AE, which is the bottom medium one, medium in terms of length, and we relate that to the bottom middle one, shorter one, which is CE. Okay, why don't you go ahead and stop the video now, do the next few yourselves, and then compare your work with my solutions. DE, the middle vertical one related to FG, the vertical one on the right, has to be the same as BD, the top middle one related to DF, the one to the right. In number 6, BD to DF has to be the same as CE, the bottom middle one to the bottom right one. AC to AG has to be the same as AB, the short top one, to the long top one, AF, and AB, the short top left one, to DF, the right short one, has to be the same as AC over EG. Hopefully you got those same answers. Good job. And now let's move on to our third and last proportionality theorem. The triangle angle bisector proportionality theorem states that if a ray bisects an angle of a triangle, then it divides the opposite side into segments proportional to the other two sides. What does this mean? Let's look at a picture. We have angle C being bisected by ray CD. So we are creating two segments AD and DB. Now please note those segments don't have to be the same size because the angle here does not have to be a right angle. But what definitely is going to happen is that AD to DB is going to be the same ratio as AC to BC. AC to BC. And on to some examples. And here you can see it better. You see that AB is not perpendicular to CD. Therefore, AD and DB don't have to be the same size. So here we're supposed to solve for the missing side lengths. So let's set up our proportions. And again, we can do this in several ways. We can relate 3 to x and 9 to 12. 3 over x has to be the same as 9 over 12. Now before we start multiplying, let's simplify 9 over 12. Both numbers can be divided by 3, and we get 3 over x is equal to 3 over 4. Well, there you go. That means that x has to be equal to 4. That's one way of solving this. We could also have done it a different way and related 3 to 9 and then x to 12. So then 3 over 9 have to be the same as x over 12. And let's again reduce. 3 and 9 can be divided by 3. We get 1/3 is equal to x over 12. Let's cross multiply this time. 3x is equal to 12. Divide both sides by 3, and x is also 4. So both ways we get the same answer. In example 10, we have to be a little careful because we are not given the length of segment TR. What we are given instead is the information that the whole distance between P and R is 8. Now we already have PT, which is x. That means that TR has to be 8 minus x. So those are the things that we need to look out for. But once we have done that, we can go ahead and set up our proportion. And we can relate x to 8 minus x. And relate that to our other sides, 3 over 9. And again, we always have to match the corresponding parts. So we went from the top to the bottom, so we have to do that for x and 8 minus x, as well as for 3 and 9. 3 over 9. And again, we can reduce this. This is equal to 1/3. And now let's go ahead and cross multiply. 3x is equal to, any time that we have two terms in the numerator or denominator of a proportion, please don't forget to distribute. Now this time we're distributing a 1. That's easy enough because we don't have to distribute much. The parentheses can get rid of right away. We get 8 minus x. And now let's go ahead and solve this. Add x to both sides. 4x is equal to 8. Divide by 4. And x is equal to 2. One look back at our instructions. Solve for the missing side lengths was what we were supposed to do in both problems. Number 9, we got x is equal to 4. Number 10, we got x is equal to 2. Excellent. That's it for today, and I will see you in class.